Right, so now we're going to be doing the inversion of what we were doing in the first place. And I'm going to be honest, this one drove me around the bend. I found this one quite difficult. So I spent quite a bit of time on it. So what we were doing before, we were saying that x points, or x percentage of points is less than this point. And so that was pretty easy because we didn't even need to sort the data because we knew that, okay, it's the 49th one out of the, whatever, 200 points. We can just use the probability function, job done. But now he's asking us to say 25% of the data is less than or equal to blank. So like in these data, we have all these weird data here, loads and loads of points. So let's say whatever 75% or less than that one or whatever. So we're going to have to make a function that figures out how that works. It's called, so he's named it percentile. So let's define that first. So define percentile. And then I think he gave us something that we wanted to use as a, yeah, PPP in data. So we'll take those two arguments. So the data is always going to be x, which is defined up here. Sorry, it's defined down here. So the first thing we're actually going to want to do with this one is sort, because we do need to sort this one because we're not working off general values here. We're working off this exact data. And I'll explain up here that we're going to suppose that the cumulative distribution function is linear between each pair of values. So we just basically get the average between it. So we use this function here, n minus 1 multiplied by z over 100. So let j equal to n in this case is the length of the data, so it's x, multiplied by the percentage, so ppp, divided by 100. So this is the exact x value that we want, right? But we're going to suppose that there's 2 points between it, because this is going to end up being it's not going to be a whole number, it's not going to be an integer. It's going to be a strange one. So what we're going to do is we're going to turn it into two different integers by using a function called np to floor, as we were showing here. Np to floor of j. Oh, I should call it j. So I think he called them like L and C or something. So we'll keep, yeah, L and C. We'll go with that. So L is equal to np floor. So what that does, let's say something is 3.5. The floor of 3.5 is 3. And then for C, we'll call it the ceiling. np.ceil j. So that's going to be the ceiling of j. So the ceiling of 3.5 is 4, for example. Now, we're going to use the interpolation function to do this, but it's a strange one because obviously we're using two different points here, but we'll also have this middle point. So we're actually going to let the middle point equal to x here. So we're going to make a x value is it going to be equal to, so dl, so let's be data of the L1 plus dc, so that's data c. I'm working off this function here, by the way, minus data L, and then multiplying. So what he says here is z over 100, but I found that doesn't work. I think it's actually j, because that is the exact point that we're working with, minus L, which is the first point, and that was what he was explaining when he was explaining the interpolation function. That's what he said. So the L then is just literally L. So we'll return that x value, and that should sort everything out. Now, again, this one drove me around the bend, and errors were nearly always. Oh yes, this was a thing. This was one of the weirder things. So if you look up here carefully, unlike I was, he puts integer around this because for some reason it doesn't make it into an integer. I don't know what it makes it into, but we're just going to put int around these. This is a common mistake, yeah. It's a stupid mistake that I kept making, and obviously I didn't learn from it, but hopefully this time, with a bit of luck. There we go. So if we run the test there, that should be okay. So yeah, hopefully you understand what that one was kind of going for. It wasn't the easiest one, so fair play to you if you managed to understand it.